Okay, it seems it's working. So good morning everybody. My name is Alen Salamun. I come from Real Security, and due to big problems we saw a couple of years ago, 2 years ago, we decided to actually create our own crypto wallet, not because it's easy, but because it's hard. What can I say? The problem was that what we saw up to that point was terrible. I mean, the applications didn't work, the hardware didn't work, the display didn't work, the upgrade didn't work, and the user experience was terrible. So we asked ourselves, how can we make that better? We come from a company that only deals with security for 20 years. We dealt with PKI, we dealt with HSM in banking, stuff like that. And digital currency, let's be honest, your private key is PKI. Yeah? So it's old technology brought to something new. And actually, we all have one big problem. Users don't know that. They don't know that, well, blockchain is a ledger out there which you can use through functions which you execute with your private and public key. And that's it. Nobody knows that. 90% of users of currencies in crypto don't know that. They think they're holding the wallet with the contents here. This is my Bitcoin Cash. No, it's not. It's not here. They don't know that. So you have to start with that first and let them know that actually they're just holding the key to a drawer, and that's it. If you open the drawer, you can, well, do something with the content. And based on that, well, actually, when you generate the wallet, you get a public and a secret key. And the thing is that users don't know that the secret key is kind of a certificate, right? It's a certificate. It's nothing more. It's just a little bit shortened with base 64 and so on and so on. But I think 90% of users are not aware of that fact. So why would they understand how to keep it secure? They think if they install a crypto wallet application on the mobile phone, which runs on Android, it's secure. It never will be secure. Why? We're talking Android. By default, you cannot do a transaction and sign it on the same device. This is for 30 years. You have special devices which are called HSM in banking. What do? Exactly the same stuff. The private key is in the device, never leaves the device, and you request something and say, I am the one who can do the transaction. The device checks your credentials and says, yeah, right, I can sign your message, and sends out the signed message. If you open the device, it wipes everything. You can never get the private key. This is HSM. This is 30 years old technology. And people think crypto wallets are new? No, they are not new. This is what we're using for 30 years. The problem is that people don't know that, and they use technology which they think it's new, and they use it wrong, and they don't get the facts right. And this means disaster. Plain and simple. So, one of the first things for any owner of crypto is, well, where's the private key? Because now that I know I need a private key to do anything, where is it? So you have to ask yourself, where is the private key? Who has access to it? And well, can you somehow securely store it, backup it or something? Because things happen in life. You lose stuff, you forget stuff, you get stuff stolen, and so on. And this is exactly the question why everybody should read that. That's a book about hardware security modules, HSMs. the technology I said is like 30 years old. It's out there for everybody to read and to understand what actually a crypto wallet does. It existed before crypto wallet. You just switch the HSM with crypto wallet, and that's it. You get everything out of one book. The thing is, you generate a private key of the internet, of everything. Nobody can access it, because, well, how do you access something that is not connected? You can just physically disassemble something. And that's it. I mean, crypto wallet, right? You take HSM, crypto wallet, done. That's it. Thank you for your presentation, and no, it's not that easy. The thing is that we have following problems mentioned by famous founders from Ledger and Trezor. So they have like a battle. Like, yeah, we found this. The first thing they mentioned was supply chain. The second thing was issues with software. The third thing was, of course, issues with hardware. So we have actually 3 attack vectors which we have to cover. And those attack vectors are actually valid for anything IT. So it's not like only crypto wallets, it's everything IT, same stuff. And well, we forgot one. You are the biggest problem. Everybody here, you guys are the biggest problem for IT security. If you guys would be educated, I wouldn't have a job. And if you guys would be educated, downstairs there would not be a conference with 500 people. Because we wouldn't have to do it. Nobody would have issues. So the humble user is also very important attack vector. Actually the first one, the most significant one, and the most problematic one, and the one that you cannot solve. You can. It's impossible. So let's look at it point by point. We have the supply chain. Well, with supply chain, the thing is that that's valid for any vendor on the planet, except the ones who produce their own chips, who produce their own software, who produce everything in their own factory, and pack everything in their own factory, and ship everything by their own shipping facility, and sell everything in their own stores. So how many of those do exist? 0. Exactly 0. Nobody owns transport company, a store, manufacturing, and everything by themselves. Nobody. Supply chain attack means somebody can access your devices somewhere in the whole spectrum from the factory to the end user. So this is something that's valid for everybody. Any kind of vendor, any kind of smartphone, whatever. Supply chain attack is there. It happened. You maybe know about things from many years ago where certain kind of Cisco routers had certain kind of stuff in them that Cisco said, we don't know. It was shipped to some countries and there were some extra modules built in by certain agencies. That's supply chain attack. Used in Cold War in Xerox machines. So when the Russians bought Xerox machines for the embassies, there was already an extra model for free in them. And this extra model made copies of everything. That's supply chain attack.
Golden ticket, they call it.
Yeah. So the thing is that you can just minimize the risk when you are buying stuff directly from reputable vendors. You don't buy from some Chinese place that might, by the way, sell you fake electronic chips. This happens a lot. And while you can produce stuff in your own facility, this helps. You can pack stuff in your own facility, and generally speaking, you just find partners that are reliable. Of course, you will never be able to say 100% sure that this works. Because if one person is corrupt and somebody, like shipper by the shipper, they can switch the product. If one person is liability, you can never guarantee it's not going to happen. So actually, supply chain attack is always possible, but the risk is that small. It's a calculated risk. You cannot avoid it. You can just do your best, and that's it. I would say it's risk rating C. It can happen, but I cannot prevent it. I can put 1 million of hologram stickers and boxes and whatever on the device, and maybe I will prevent it, but it can still happen. So the next thing, the next attack vector is the software. That's a problem. If you look at the hardware crypto wallets, they have to use software. Why? You cannot do blockchain transaction without knowledge of the whole blockchain. It's not possible. Well, with some cryptocurrencies you can do it, but with major cryptocurrencies you can't. People don't know that. People don't know that if you want to send your Bitcoin Cash, whatever, you have to take all the inputs of everything you got, find them exactly, calculate them together, and take the amount that is equal or more than what you are trying to send, and then create a transaction. And how can you do that? Only with the complete blockchain. That's 77 gigabyte of data just for Bitcoin. And 77 gigabyte of blockchain is just the blockchain, it's not a database. You can use it as a database. So imagine, you want to have 77 gigabytes of data here just to pay for something? It doesn't work like that. So you have to use the software. And the thing is that, well, software will always have problems. Always. Why? You use libraries, external libraries. JPEG, networking library, the main library for operating system like glit in Linux or stuff. Those libraries can introduce problems. And you're not the one that's guilty, but those libraries can introduce the problem. And you will have the problem in the software because of that. Of course, software is running on operating system. So operating system has a problem. Your installed software has a problem. Your drivers have a problem. Your computer has a problem. Your BIOS has a problem. That's all software. And then people ask you, oh, why is your wallet not open source? Well, is your operating system open source? Is everything up to the level of the wallet open source? No, it's not. You're running Windows. So you're asking me if you can trust me running software on a closed source Microsoft operating system that can control anything. Yeah, right. And I'm the one that you should be afraid of. If you catch me doing bad stuff, I'm done. I can close the company. If you catch Microsoft doing bad stuff, they say, we didn't know. Cisco routers. More than 10 found backdoors in last 10 years. I'm talking about backdoors. I'm talking about certain privilege. You type in the user, you type in the password, it works on any router. So everybody was crazy switching out Cisco routers? Nobody did it. They simply didn't care. And this you have to be aware of. It's not just the software, it's not just the application, it's everything up to the point of application that's also the software. So now we can agree that no critical information should be stored anywhere near your computer or the phone, because it's not trusted. You can never trust your phone, never, ever, because it's whatever operating system you're running that has issues. You can rootkit iPhone, you can rootkit Android even easier. So who says your phone was not jailbroken before you got it in a box? Because we talked about supply chain attack. And this is why you don't keep critical information in software. Simple as that. Never. So Samsung, new phone, S10, has built-in crypto wallet. good stuff. Many users gotta find out they have crypto wallet, which is good for us. Is it secure? No way. It will never be secure because there is an operating system and the fact of the user can do nasty things in this operating system. So by default, Samsung is doing a good thing, but it will never be secure. Because you cannot generate private keys or use private keys on one single device, and we will see why. Of course, the channel between the software and the hardware should be somehow secured. This is a big discussion of should crypto wallets, hardware crypto wallets, have Bluetooth? Should they have wireless? Maybe. But this is additional attack vector. You're introducing Bluetooth, you're introducing new attack vector. You have to take care about the Bluetooth now. Will Bluetooth make some kind of security issue in the future? Maybe. Maybe they will have to upgrade the protocol, the standard, the whatever. And you have a crypto wallet with built-in hardware chip that you cannot switch, which is now considered insecure. What do? The good thing is you try to convince the user to buy a new one. Well, it seems it's a good thing, but it's not. And, well, I mean, you can write the software with accordance of security guidelines that there are tools available that we use that scan your software and find out if you have typical problems of buffer overflows, of uninitialized variables, and typical security issues that programmers can do, because they do make bugs. They do make mistakes. And you can catch them, but not all of them. So you can, again, never be 100% sure that everything was found out. Even encryption algorithms change. Nowadays, you have to use TLS on HTTPS. SSL is considered unsecure. So people are still using it, the old algorithms. Then again, these things can be followed, so you check your information. Oh, what is considered secure today? Okay, good enough, we'll take that. So no problems there. You can switch the encryption algorithm in the future with an upgrade. So if encryption algorithm fails, everybody's gonna fail. That's a fact. When AS256 will be broken with whatever technology, quantum computing, whatever, everybody's gonna have a problem. And, well, man-in-the-middle attack is the stuff of nightmares for the user. Because it's the easiest to do and the best way to do it. I don't have to have your wallet, I don't have to see you, I just want to have access to your computer and that's it. And you can have the best hardware wallet on the planet. Man-in-the-middle attack can be executed on the software side, and we will see also on the hardware side. And this is one of the main attacks you have to prevent the user from. And the user is not careful. They don't check their data, as we will see. So these are all the attack vectors that have to be taken care on the software side of not only crypto wallets. That's actually valid for anything that does something important on a computer. So the matter of fact is that tampering of software is something that can happen any second. I can access your memory and change bits, whatever I want to, if I have access to your computer. That's easy. I can override your memory protection, I can override your operating system, I can do whatever I want if I have control of your computer. And I can do it remotely. You will never notice it's happening. And the attacker never wants to expose himself that he's doing something, because then you see it, then you call some of your friends to fix it or whatever, and this is not the purpose of attacker. If I'm the attacker, I want to be incognito on your computer as long as possible to see what you can offer me. I'm gonna wait and see, oh, crypto wallet, boring one, nothing on. Another one, boring one, nothing on. I'm not gonna do anything. until to the point where I see something valuable. And this is why the hacker will always try to first find a problem in software. So, risk rating between A and B. It's really risky. We can do some stuff, but I think this is, well, one of the highest risks for any user of crypto wallets. And then we come to the hardware. This is the funny part. Trezor, Ledger again, yeah, we can install rogue firmware on your device. And they're saying back, yeah, we can install rogue firmware on your device too. Yeah, that's true. You can install a rogue firmware on Apple iPhone. Jailbreak, right? You can install a rogue firmware on Android. So, can you prevent it? No. You cannot prevent it. This doesn't exist. Except if you cut the lines on the chip that enable the chip to write to flash for firmware. So you can physically cut the pins. Then you will prevent it, because it's, well, not doable. But otherwise, rogue firmware problem is always an issue. You can try to make it hard for somebody to do it, but you cannot prevent it. By the underlying technology of how microcontrollers work and operate, you cannot prevent it. If Apple couldn't prevent it with amazing amount of billions of dollars, well, probably it's not doable. Side channel attack, again, last week, Ledger to Trezor, we can do side channel attack. And Trezor back to Ledger, we can do side channel attack. And user, what the hell is side channel attack? So, somebody's gonna attack me from the channel in my street or what?
No, from the side.
From the side, yeah. So, this is highly sophisticated stuff, which can be explained really, really simple. If you compare the password, character by character, and measure the amount of power the microcontroller uses, you can see which character is correct one. Why? Because you type in the wrong character, the microcontroller doesn't use much power. You type in the correct one, it jumps up. Why? Because you just executed a decryption loop. How can that happen? Only if you have bad algorithm set up for doing stuff. You never compare passwords if you want to do something secure, as we'll see later. The thing is that actually, you can do it even remotely. I can listen in on your PC speaker, whatever, wires, I don't know, amazing stuff, and get this information from the distance of 10 meters. But this is really stuff of NSA and CIA and so on. Nobody's gonna attack you with that. Because it's simpler to come up, take a gun, hi, I want your Bitcoin. You know, if somebody is prepared to do that, much easier. Usually, you get the password quickly. Then again, we have man-in-the-middle attack on the received data. And well, this is the point where maybe we should explain what's man-in-the-middle attack. Again, it's not man coming to your apartment and hitting you in the middle of the eyes. That can be considered man-in-the-middle too. As we noticed, there's two ways to do man-in-the-middle. The software side is simple. You type in, you want to send me 1 Bitcoin. I'm waiting on the computer, I see this, I change the address. So you type in my address, which is some blah blah string, and then I change it to something else. You confirm the transaction, this goes to the device, you see the transaction, and everything is okay, click confirm. That's man-in-the-middle attack. Man-in-the-middle attack on the hardware is exactly the same stuff, but the hardware does it. So, how would I do that? I could give you rogue USB cable. So, I could change data on USB and convert the address if it would not be encrypted, or if I could decrypt it. Or I install rogue firmware. So my rogue firmware would do what? Everything exactly the same as the normal one, except when you send me 1 Bitcoin, I would also show that you are sending me 1 Bitcoin, but I would send it somewhere else. Because when you request the signature of transaction, I show you on the display, everything is correct. You confirm, I sign, and send back to the software the changed data. This is man-in-the-middle attack on the hardware. Well, but for anything here, hacker has to physically gain access to your device. He has to take the device to his lab, use oscilloscope, connect it, use quite expensive equipment to do it, and so on. But first of all, he has to have your device. So he has to steal it or something like that. Nobody is gonna find your crypto wallet on the floor, pick it up and say, oh, I'll do a side channel attack now. People's gonna find, oh, a ledger, probably worth something on eBay. This is what they do. People don't find things and do side channel attacks. No, that's stuff of labs. That's a theory attack that can be done on bad crypto wallets. But it's highly unlikely that somebody will target you. Somebody might target you if you are a big stock exchange, or maybe Roger Ver holding a lot of stuff on your crypto wallet. But otherwise, no. And if you are a big exchange that has 100 million of crypto in crypto wallet, you probably don't carry it around in your pocket. You still secure it, right? So risk rating C. Well, yes, it can happen, but I don't know. This is not the problem you have to think about. Because this is the problem you have to think about. This is the biggest problem, because the user, the humble user, that enables us to have conferences with 1,000 people attendees, 2,000, 3,000, 10,000, and so on, is the source of all evil. And the thing is, if the user would be smart enough, we wouldn't have a need for hardware crypto wallet, probably. They buy device from untrusted sources. What happened with Ledger? A smart Chinese guy sold Ledger on eBay with predefined 24 words. You had a scratch card like that with predefined 24 words, which you scratched off, oh, I should use those words. And user did that and stored like $30,000 on that. He didn't even read the manual that this is not the correct way to initialize the crypto wallet. So how do you prevent that? You can't. It's not possible. If user is so stupid, you better not sell in crypto wallet. So that's the prevention. You cannot prevent that. So the only way for the user to avoid that kind of attack is to purchase it by a reputable dealer in a reputable store or directly from the producer. And that's it. Infected desktops. I like that. There are millions and millions of users right now that don't know they have infected desktop. They are mining Monero probably. If they had a little bit of luck, it's just mining Monero. If they didn't have luck, it's ransomware just right now switching on the display where they are demanding 1 Bitcoin. Maybe somebody is just looking through their data right now, trying to find some crypto wallets, trying to find some passwords, stuff like that. But this is #1 issue, infected desktop. This is why hardware crypto wallets exist, because this is considered true by any means. That your desktop is infected, it's not to be trusted. And many vendors that actually use crypto for signature of data and stuff like that, use that only because of infected desktop problem. Otherwise, you agree to something on computer and that's it, right? You send off the data and why would you bother? One more man-in-the-middle attack, which can be done by your mouse or the keyboard. You know you have copy-paste buffers. You copy data, you paste data. You know you copy data on iPhone, you can paste it on iMac or Mac. It works seamlessly. So I copy something here, I go to my computer, paste, works. But here I am, waiting for you to do it, and I change the data. Very simply. You get an email from me, I send you, please send to my address, da, 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 da. You have a Logitech mouse, the newest one. You copy the data. Did you know the mouse stores the data in the mouse itself? Why? Because it has a great feature that enables you to copy paste between computers. So you can have one mouse, 3 computers, select something, copy, go to that computer, paste. It works. But this mouse stores the data. I attack your mouse, I get the data. I do man in the middle on your data, on your mouse, to switch out the address. How will you notice? It's a string of hex characters. It's doable. Or even better, I get a nifty little USB plug-in and put it in front of your keyboard. Man in the middle on the keyboard data. No problem. Easy. Phishing is cool. So we all know, send me 1 Bitcoin, stuff. Some people did. So how would I help such person? Well, stay away from crypto. That's the help he needs. Not comparing the data that is sent from software to hardware, again, is a problem. You copy the address, you send it, the display of the hardware wallet should show you all the data, and you have to visually go through. Is this the correct address? Yeah, it is. Did you know there is service that enabled you to generate predefined crypto addresses that look like something you want? So you paid money to people to try to get the address of crypto wallet in a way that you would like to have it. For example, the first 6 characters should match something else, or the last 6 characters should match something else. So this is doable. You could buy Bitcoin address that has 6 characters at the end in a form you would like to. So if person is just comparing the last 6 characters, works. Got it. I just switch the address that looks almost the same as his. If he's not careful, he just signed the transaction. I like that. That's excellent stuff. We just had a case of that. Users are completely clueless. What is ERC20 token? What is Ether? What is Bitcoin? What is Bitcoin Cash? And Bitcoin whatever Cash SV, I don't know, there's like gazillion of same stuff out there. So what people do, and one of the users did also, they set to the wrong addresses. So they take Bitcoin and send it to Bitcoin Cash address. This is actually somehow solvable if you have a private key, so it's not a problem. Well, it's a problem, but you can solve it. You cannot send Bitcoin to Ethereum address. Mostly. Why? Because the address format is completely different. So if you're using a proper exchange, if you're using a proper application, the application will say, no, that's not okay. The address you are sending to, that's not Bitcoin. That's something else. But the problem is that when all this new crypto is born, they just copy the format of the address from Bitcoin, Ether, whatever. And they don't change it. So we cannot prevent that, because there's no way to prevent it. It's the same address. And again, how do I have the user here? You can show him, you can try to warn him, but they will do mistakes again. And this one is really great. How do you attack the user? You try to get him to use web service for transactions. And that's, again, the easiest way to hack him. Ledger used web interface through JavaScript to do transactions up to the point where they released new application, right? That doesn't support 3/4 of their coins, so you still have to use the web application. And you have to use services as MyEtherWallet to do any kind of transaction with the tokens with Ledger. So how do you attack you? Do I go hack your side channel attack Ledger? Why? I'd rather hack your browser. It's really simple. I'd rather do man-in-the-middle attack on the MyEtherWallet. I send you phishing. MyEtherWallet just changed address to myetherwallet.car. People click on it, it looks the same, everything is legit, and do stuff on there. And this is, again, one of the easiest attack vectors for the hacker to gain access to your phones. So how do you solve that? Well, you don't use third-party websites for main important stuff. Because you cannot control security of third-party websites. And of course, forgetting password PIN, that's the best one. We get support emails like, oh, you know, I forgot master PIN. So how can I access my data? You said, well, you can't. No, I mean, how? You know, there's a way? No, there's no way. Oh, okay. And that was the last you hear from the user. They do forget passwords and they do forget PINs. And what do? Well, they use simple password and simple PINs not to forget them, right? So you enforce 16-character password for the user. 16-character password, he's gonna probably, I don't know, do just A's or B's or whatever, because he will not remember the 16-character password. So what you have to do is you let the user choose his own way of how to do it. You warn him and tell him, if you use simple password, it's your problem if you get hacked, not mine. But do it in a way where you feel comfortable. Maybe for somebody, 30-character password is simple because he's just typing in the sentence, I am the best hacker. That can be password. Or for somebody, maybe PIN is easier because they can remember 10 numbers. So let the user choose the method, but warn him what is not secure. And of course, we have that too. $300,000 transaction fees on Ether. That was like 1 month ago. And now it is confirmed, for that transaction, it was confirmed that was a mistake. Because the exchange paid half of it, 150,000, and the user paid half of it, 150,000. They reached agreement. A user made a mistake. So how do you prevent that? Well, it's good to show the user the transaction fee in the local currency before he sends the transaction. And it's good to warn him, look, I mean, $300,000, are you sure? It's not easy to pre-program the user not to do mistakes, but it's really easy to have solver checks for the user. So it's a simple dialogue. Are you sure? This looks like not good. And when he sees the $300,000 fee written, he will say, oh, shit. But you have to translate it to money for something visual for him to understand. Not like 0.015 of some kind of cryptocurrency. Because he cannot imagine what just happened. You have to show him plastically. And of course, backup issues. This is the great one. So again, how do you do backup your crypto wallet? You have these 24 words which you have to store. I get your words, game over. How do you encrypt your 24 words? I don't know. Maybe you change something in every single word, but then you forget that and it's not usable anymore, so you can't. But you need the backups. Because users tend to lose devices or whatever. They break, they fail, they fall in water. you have to have a system for backups that's secure and doable. So this is risk rating A+++. It's the user. So everything we do is about that. And well, in 2017, we said, damn, we can do this much better. I literally was jumping around the office every day and screaming that I will find these guys that made Ledger and I will expose them that they didn't use 70 million of funding for this. Maybe for Lambos and stuff, that's good, but not for Ledger. Because this is a piece of crap. And it still is. So supply chain, how do we protect against supply chain attack? Simple, we can. So we can just do best we can do, and this is, the FRAM is a chip by us that stores your crypto private address. We buy directly from Fujitsu. So Fujitsu, factory, real security, that's it, both done. Still, somebody shipping the chip could switch it out or something. But it wouldn't help him. Because when we initialize the wallet, when you initialize the wallet, you wipe everything. You don't have anything on FRAM because you simply don't have any wallets. So that's not the problem. Microcontroller and everything else is bought directly by big worldwide suppliers that everybody uses, like Mouser and stuff like that. So you don't buy by shady dealer. Again, microcontroller is flashed with the firmware at our facilities by us. We don't let Chinese people do it. Everything is done in Slovenia directly by us. The project is registered by producers of components. So when Fujitsu makes FRAM, they know it's for us, and when the producer does OLEDs, they know it's for us, and so on and so on. PCB assembly, Slovenia. Slovenian big companies, which you are not aware of. Probably you didn't know, but in Slovenia you can assemble 100,000 PCB boards per month, no problem. You have facilities like that. And of course, final assembly done in our facilities. So we do the programming, we do the flashing. We don't trust anybody else to do it. And well, that's best we can do. Complete production cycle in Slovenia, even for plastic parts, even for buttons, whatever. Everything is produced in Slovenia and assembled in Slovenia. So what can we do about the software? First of all, we have a certificate for our application. So you run it in Windows, you don't get any notification because it's certified by a certificate which is trusted by Microsoft. And the same for Apple. So you run Apple application, you don't get the warning, sorry, this application is from untrusted developer, blah, 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 bullshit. Because if you get that, the next time you're gonna install the rogue application, you're gonna get the same dialog. Oh yeah, that's okay. With our application, you will not get it. Doesn't cost a lot of money, doesn't take more than a day to do it. Software vendors are not doing it. Because, well, they don't care. But this is prevention of rogue software. Because only software which is signed and trusted from Microsoft and Apple that is made by real security is the legit software, and done, that's it. So you want to install rogue software, you're going to have much more harder problems to do it, except if user is ignoring the data. So he said, oh, BC Vault desktop software version 3 made by some Chinese characters. Yeah, we don't trust, okay, no problem. So again, user problem. Client and the device communicate over USB cable, the communication is encrypted, you have all these certificates, just to prevent man in the middle on the cable, man in the middle on the communication channel between the device and the software. Critical data is always read from device. Did you know Ledger actually stored wallet addresses on your PC? So if you change the address in your file, Ledger told you the wrong address. That was actually great attack vector. So you just change the wallet addresses, and when the user was like, yeah, I want to send something to my wallet, my address, you got the wrong one. They fixed that, I think, years ago. But you never do that. You have to read it from the device every single time. You don't trust the desktop. That's funny. Because I think Tresor didn't have passwords on the desktop side. They just had the PIN, right? So if you could read the PIN, that's it. Game over. You have everything. Ledger had the same issue. They just had the PIN before. You read the PIN, game over. Well, we have password and PIN. So password, PC side, PIN, device side. Why? I can use really long password. As I said, I'm the best hacker. It's really good password. In combination with the PIN. Because if you take the I'm very good hacker, which is probably in hash tables already correct, and add just 3 pins to it, the problems I'm imposing on attacker are exponentially bigger. Because when you type in the password and the PIN, our device doesn't know which part is correct. Never, it doesn't know. It just uses everything together and says unlock data. Doesn't work? No, it's not right. And that's it. We don't know, the device doesn't know, the software doesn't know if your password is okay or your PIN is okay. Just everything together. And even then, we don't compare it. And this is really important to prevent side channel attack. Why? Because, as I explained, side channel attack, it was comparing each pin number, and you could see which is the right one. We don't compare. There's nothing to compare to. You cannot do side channel attack when you are not comparing the password. Well, at least on that kind of scale. Because what we do is we take everything and we try to unlock the data. And if the data comes out unlocked, well, that was the correct password and PIN. But if the data comes out wrong, we just say, doesn't work. So how do you side channel that? Well, you can't. Because the only output you get is everything together is wrong and everything together is right. And that's it. Of course, software is written with security in mind. We have checks to prevent buffer overflows. I will not go into that. It's too complicated from the software side. But you do your best effort, as everybody else. And still you can have issues with some software library you are using from OpenSSL, which you are not responsible, but it's there and you will have to fix software. Of course, we have one software branch for everything. We don't maintain 3 software branches like Linux and Mac and Windows. No, it's one. We have one source code that compiles on everything. And that's it. Anything we add works immediately on all platforms. Because then we just have to fix one thing, not 3 things. And, well, as I said, man-in-the-middle attack can be made in software. And this is why we have really big display. So the user checks the data on BC Vault and compares it to what it was typed into the computer or copied. You have to check your data all the time. Source address, destination address, the amount, and the transaction fee. Why? Because the transaction fee actually can be exploited. I can change the transaction fee in my favor. And then, as I said, of course, changing the design in a way where you enter the PIN code, which is not numbers, helps a lot. Because numbers is easy to hack. You try 1 to 9, 1 to 0, sorry. We don't have numbers. it's directions. But even directions are not directions. We don't treat it as up, down, left, right. We do something completely different, which we don't tell. Why? It's much, much harder for possible exploiter to exploit that. So the hardware, again, has active and inactive firmware storage. You do upgrade to firmware, something goes wrong, no problems. You are upgrading the non-active partition of firmware. Whatever, you can pull out the plug, you can pull out the power, whatever, doesn't matter. Once we do the firmware upgrade, to the end, we switch the bootloader to the other partition. Simple. Why didn't Ledger think of it? Well, they use 70 million on Lambos. So we use FRAM, not flash. FRAM has property of storing the data without electricity for 10 years at 85 degrees Celsius. You're not storing your crypto wallet with 85 degrees Celsius, but just to let you know, flash has problems. Flash has much less read-write cycles. You can ruin flash by going repeated read-write in one day. You cannot ruin FRAM with doing that. Why didn't competition use FRAM? Well, costs a little bit more, right? And then we set password and PIN. It's not stored on device, I already explained that. And, well, the thing is that if you do man in the middle on the device, the software checks if the signed data that came back from the device has everything as it should be. So from, to, amount, and everything else is compared again with the signed message, if everything is cool. So we know man in the middle couldn't be done on hardware. Well, I told you about PIN has all secrets. They are good. I will not expose that. It's a security feature. And well, as I said, everything was designed and developed by us. We don't buy stock stuff. Everything is designed by us. Even down to the smallest component. By the way, we have a gyro sensor, which you have to shake to initialize to generate random number. Why? This is the only way you truly have random number, because you have to like shake it random. Yeah, we have to pay for that gyro sensor, right? So why didn't the others use it? Well, they didn't care. It costs money. And then we have the user. So the device actually has best effort to warn the users when they're doing something stupid. They have a possibility to do backup whatever, in whatever way they would like to. SD cards, paper. You choose. You want to have backup without passwords? No problem. Change the passwords to 0. Just leave them empty, confirm. Do the backup, and then change them back. And you have backup without passwords. You want to have backup with passwords? Well, do it with passwords. So user has an option to do whatever he would like to. Or she, of course. So you prefer paper? Go ahead. You prefer micro SD cards? Go ahead. You want to have 20 micro SD cards? No problem, have 20. You have like unlimited numbers of backups. Just throw them at your family, whatever. Tell them, store this card, and when I die, find somebody and he will help you. You can do that, no problem. And then, well, everything that deals with sensitive stuff, like erasing something, deleting something, you warn the user. You're telling, look, if you're gonna delete Ethereum wallet, which you don't allow yet, because of security concerns of user doing the mistake, you are gonna to delete all the tokens on this wallet. You have to tell the user, because he doesn't know. Well, each wallet can have its own name, its own password, and its own PIN. What can you do? Simple. I give you the password, I have the PIN. Only when we are together, we can do the transaction. Done. Simple multi-sig done in seconds. So it takes 2 of us to do it. Or if I give him the password, and him the password, and the other 3 guys, I give them the PIN, that's it. They can do it. As I said, the backups are encrypted. Yeah, she's gonna take me away, but I'm just gonna talk. So, you know, that's it. This is on purpose, by the way, because I know where they're taking me. And, you know, you check the addresses. So, that's last slide, by the way. So, as you see, not to take any more seconds, I'm just switching to the last slide. Thank you very much. That was basically the intro.